Hello everyone. So welcome to this GOC quick synopsis. So in three part we will complete this GOC, each and every concept. So in first part in this we will discuss formal charge, then after intermediates, transition states, carbocation, carbon free radical, carbanion, their characteristics, and then after electron displacement in that temporary displacement of electron and permanent displacement also will try to cover as much as possible in this part 1. So let's start. First we will discuss formal charge. So formal charge in chemical bonding you have studied that Lewis gave that this hypothetical concept to calculate formal charge when that octet rule was getting disturbed. Then he introduced this hypothetical concept of formal charge. So formal charge, and theoretically that formula is given that valence electron minus 2 into lone pair minus bond pair. Let's suppose this entity is there. So in that chlorine formal charge we are calculating. So valence electron is 7 minus 2 into how many lone pair? Total 3 minus bond pair. How many bond pairs are there? 2 bond pairs. So overall formal charge is coming minus 1. Another way also we can calculate, which is shortcut and very effective. Like suppose for example, this is the second period elements. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So here that lithium is 2s1, so it having valence electron 1. Similarly beryllium 2, boron 3, 4, 5, 6, 7, 8 respectively. So here we are seeing that chlorine formal charge we are calculating. Let's suppose formal charge is not known to you. So fluorine, in that chlorine is coming, so it having valence electron 7. If valence electron is here 7, now we are calculating how much chlorine having total electron. So 2 to 4 to 6, and here chlorine having mutually shared 2 electron. Means one bond in that, 1 electron is of chlorine, and here also 1 electron of chlorine. So total here 8 electron. Chlorine should have total how much? 7 electron. It having 8 electron. So here it is minus 1. Means whatever the electron extra from valence electron is considered its minus formal charge. And whatever the less electron is there from its valence electron, that much positive will be its formal charge. Like here you can see nitrogen should have 5 valence electron. How much electron it having? Only 4. So plus 1 charge. Carbon should have 4 electron, but how much carbon having? Carbon electrons only 3. So it is plus 1. Here carbon having 5 electrons, so minus 1. Here carbon having 4 electrons, so it is neutral. So by the way, this is called carbocation, this is called carbanion, and this is called carbon free radical. In organic chemistry, by two ways we will break the bond. So one is that homolytic bond breaking, and another is that heterolytic. So homolytic bond breaking will happen in that non-polar solvent like CCl4 in presence of heat, either HNu or heat. So by that this bond is breaking, since that bromine is more electronegative. So it will break this side also 1 electron, this side 1 electron. So here free radical generated. Here also this bond is weak because of lone pair repulsion, peroxide bond. So here for that radical generated. So this is homolytic bond cleavage. Another is that heterolytic bond cleavage. So heterolytic bond cleavage always occurs in polar solvent. So in presence of H2, and all bond breakings are endothermic. So we are giving here sufficient heat. So by that bromine is more electronegative. So this carbon electron also will shift towards bromine, and carbon will become positive, electron deficient. So here it is heterolytic bond breaking. So in that positive and negative charge will appear. Now types of reaction. There are two types of reaction. One is single step reaction and one is complex reaction. So single step reaction is elementary reaction. In this, that for example, let's suppose A2B2 forming 2AB product. So here AA bond breaking and BB bond also breaking, and new bond is formed AB. So this state is called transition state, and after that product will be formed. Next is complex reaction. So complex reaction is multiple step reaction in that each step is elementary reaction. So here you can see this is the complex reaction. Its first step is A plus B forming AB. This is overall, its all three step is called mechanism of the reaction also. Now AB combining with B forming AB2, AB2 combining with A and B forming A2B3. So in that you can see overall when you will add, so AB2 AB2 will be cancelled, AB AB will be cancelled. So overall this reaction will come. In that AB and AB2 is intermediate. So in organic chemistry, there are 6 intermediate. In that predominantly we will study these 3: carbocation, carbon free radical and carbanion. Whereas another 3 is carbene, benzene and nitrene. Next, moving further, carbocation intermediate. So carbocation generation, that let's suppose here Rx is there, in presence of polar solvent it will break down into heterolytic bond cleavage. So this is generation of carbocation, or C plus and X minus, Cl minus. Carbocation, in that you can see this p orbital is perpendicular to the plane, and this is vacant orbital, carbon having +1 charge, formal charge, because carbon having 3 electrons only, but its valence electron is 4. So here it is sp2, Tp means trigonal planar. So it is trigonal planar. Pure p orbital is perpendicular to the plane. Formal charge is +1, 6 electron. Overall in octet, how many mutually shared? 2, 2. So total 6 electron. Octet incomplete, unstable, highly reactive and electron deficient. Lewis acid. Electron deficient means Lewis acid. Or electrophile. Vacant orbital is p. Number of unpaired electron 0. It is diamagnetic, so mu is 0. Next after that, carbanion and its characteristics. So carbanion, here again you can see Rli is there. So lithium is alkali metal. So in presence of polar solvent, bond will break like this. So this is carbanion and lithium plus. It is sp3. It is trigonal pyramidal. Lone pair will be there and remaining 3 hydrogen like this. So trigonal pyramidal, formal charge -1, total how many electron? 8. Octet complete, electron rich. It is nucleophile, Lewis base, 1 lone pair, 0 vacant orbital, number of unpaired electron 0, mu 0, diamagnetic, highly reactive and unstable because charge is decision. Next after that, carbon free radical. So carbon free radical, how to generate? That only polar, that non-polar solvent by giving heat. So this is radical generated. So in that radical you can see in this p orbital, now this is not vacant orbital, in that 1 electron is there. So it is sp2, trigonal planar, unpaired electron 1, formal charge 0, 1 unpaired electron 1 means it is paramagnetic. Total it having how many electrons? 7 electron. Octet incomplete. It is electron deficient. At least 1 more electron can come. But it is not Lewis acid, remember. And it is also highly reactive, more reactive than carbocation and all. Lewis, that number of lone pair is 0 and vacant orbital also not present. At least 1 electron here you can see is there. So vacant orbital not present. Now we will discuss electron displacement, how electron getting displaced in organic compounds. So here first we will discuss temporary displacement. So temporary displacement is due to that external reagent or external factor will happen. First one is inductomeric effect. So inductomeric, in that sigma electron temporary, for time being it will displace. Let's suppose this is RxCH3Cl without any external reagent. But if any reagent or external, if any entity is coming, let's suppose A minus. So here that it having electron density. So due to that electron density, here this bond pair electron density will have repulsion. So due to that electron will displace this side. So overall before that you can see the electron was here. Due to this A minus presence, electron displaced and it came till here. So overall displacement is delta x. So this displacement of sigma electron happened due to presence of A minus. Similarly, if we'll keep here B plus, so electron will displace left side. Understood? So sigma electron, if it is getting displaced due to presence of external factor, then that is called inductomeric effect. Next, electromeric effect. This is also temporary effect and it will happen due to presence of external species which we are keeping. And here what will displace? Pi electron. So here it is CH2 double bond CH2. Let's suppose their pi electron is here. Now due to presence of B plus, pi electron is displaced here. So total displacement is delta x. If B plus will remove, again electron displacement will be 0. Next, moving permanent displacement. So permanent displacement is three types, in that inductive effect, then after resonance or mesomeric, and hyperconjugation. So inductive effect, in that you can see that this entities, that CH3, CH2, CH2, H is reference atom hydrogen. With that reference, now reference is removed. Let's suppose here fluorine is there. So fluorine is more electronegative. So what will happen? It will attract shared pair of electron little bit more towards its side. So due to that, here that electron displacement, before electron was here, now electron displaced till here. So overall total how much displacement is? Delta x1. So this carbon, what happened? This carbon on that positive charge came. So this carbon will attract this bond pair electron. So due to that, this carbon will have some partial positive charge. So again this carbon will attract this bond pair electron. Again this carbon having some partial positive charge, it will attract this shared pair of electron. So this displacement electron, that displacement of sigma electron which is happening, in that you can see that prime displacement, major displacement is here happening. After that electron displacement subsequently decreasing. Yes or no? So here you can see delta x1 is greater than delta x2, delta x2 is greater than delta x3, and so on and so forth. Means similarly we can say delta S polarization of charge on carbon, that first carbon is more than the second polarization, because second polarization is happening because this carbon is attracting, right? Next after that, this carbon since attracting, so here triple positive, partial positive charge, means very insignificant positive charge is coming, delta 3. Similarly delta 4 positive. Means if we'll equate the polarization of charge, so here delta negative is magnitude wise equal to delta 1 plus 2 plus 3 plus 4. But since here you know that here that polarization of that carbon, that 4 polarization will be almost negligible because it is linearly decreasing. So delta 4 positive will be 0. This is distance dependent. You can see here that electron which got displaced due to that fluorine presence is relatively more than here, and here that whatever electron displaced is relatively more than here, means subsequently it is decreasing. One very important and this experimental fact which is also telling same thing, that only 10% effect observed in the next bond of I effect takes place due to electronegativity difference. What it is telling, that suppose here electron is displaced 100 amount, so it's 10% only displaced here, means 10. It's 10% means like 0.1, 0.01 like that. So that's why that here as you will come after third carbon, so almost here it will be 0. Understood? So only 10% effect will be pass forward. Next after that, here that whatever electron here displaced, it's 10% only will be displaced here. Similarly, that whatever here displaced, it's 10% only will be displaced here. Whatever here displaced, it's 10% only, means this almost negligible. That's why it is distance dependent effect. There are two types of inductive effect. One is plus I and one is minus I. So plus I inductive effect means that those atom or group, if it is attached to the chain, they will donate the electron to the chain, And minus I if means those atom or group which is attached to the chain, they will withdraw the electron from the chain. So like here plus I, so you can see that here this negative charge species. So negative charge species are unstable. They want to diminish their negative charge. They want to decrease their negative charge. So they will give their negative charge to others. So if it is connected to the chain, so it will give electron density to that chain. Since carbon is less electronegative, so its nucleophilicity or tendency to give is more as compared to nitrogen. Nitrogen is relatively less electronegative than oxygen, so it can give more electron. Since after that oxygen, here this oxygen is delocalized because this negative will go to this oxygen also, so its relatively donating tendency is less than this oxygen. Then after 3 degree alkyl, then after 2 degree, then after 1 degree, this is also primary 1 degree. So this all those having here, you can see they are having donating tendency. After that tritium, then after deuterium, and then after hydrogen. Tritium, in that bond length will be shorter, so its tendency to give will be more. Whereas that hydrogen, since its bond length will be more, so electron density is less, so tendency to give to the chain will be relatively less. Clear? You can remember also IT sector, you know, information technology. So like that IT you can remember, because in hyperconjugation it will be opposite. So IT means in that tritium having more plus I effect. Next, coming to minus I effect. So it is withdrawing the electron density from the chain. So here you can see NF3, nitrogen having plus charge, and nitrogen is electronegative. It is connected to 3 fluorine. So it will withdraw the electron from the chain. So you can remember like this: na Farhan, na Ritik, na Himesh, na Ompuri, con acidic. Then after father, collector, brother, inspector. Then after this is ester. Then after OR. Then after OH. Then after NH2. Then after triple bond. Then benzene, and then after double bond. Here you can see triple bond, in that percentage of S character is 50%. So its electronegativity is more as compared to double bond. This double bond is delocalized system, whereas this double bond having percentage of S character 33.3. So it's also having electron withdrawing tendency. So this all those are electron withdrawing groups, and these all those are electron donating groups. Remember this series also. Next, this one general understanding: as in periodic table left to right we will move, electronegativity is increasing. So electronegativity is increasing means their tendency to withdraw electron will be more, so minus I effect will be more. As we are going down, so size increasing, so due to that Z effective nucleus will be far from that atom or molecule, so overall their Z effective less means electronegativity will be also less, means minus I will decrease. So you can see here also that here nitrogen that connected to fluorine, so here it having more minus I effect, since it having positive charge also, so they are very strong electron withdrawing group. Then after NO2 and so on and so forth. After that you can see carbon. So nitrogen having more minus I effect, then after carbon and so forth. So this principle is in general principle, this one. Next, moving further, orbital diagram is very important. Here also you can see one thing, that CH3, CD3 and CT3. So CT3 having more donating tendency than CH3. As I told, its bond length is more, so electron density is more dispersed. So electron density dispersed means tendency to give will be less, whereas here tendency to give is more. IT sector. Next, moving further, orbital diagram. So orbital diagram, you can see this is carbon double bond carbon. So we can see this one, that pure p orbital perpendicular to the plane overlapping with each other like this. But in actual they are overlapping in this manner. Generally we are representing like this, but in actual reality how they are overlapping like this perpendicularly. So here we can see carbon double bond carbon, here carbon single bond carbon, carbon double bond carbon. So this bond seems like that bond order. Bond order means that number of bonds between two atoms. So here it seems like that one bond only. Here it seems like two bond, and here also seems like two bond. But in reality, as we know that double bond exists like this. So this double bond and this double bond is existing like this, and similarly this double bond and this double bond existing like this. But here you can see this carbon is just adjacent only, means here also they are overlapping like this. Are you understanding? Like in this reality. So overall we can say that here that electron is dispersed overall throughout this orbitals, because they are in that overlapping with each other in this fashion. Means we can say that here that electron is moving from, because here electron having one electron, here also one electron, and they are forming pi bond, and here also one electron, here also one electron. So this also two are overlapping, means here also electron density is flowing. Means we can say that more the electron density, bond order will be more. Means here this bond, carbon carbon bond, is not one, it is more than one and less than two. Clear? So bond order of carbon carbon is here belongs to more than one and less than 2. Clear? Similarly, some other also orbital diagram we can see here, like this is, so here you can see NH2, so NH, so this nitrogen having lone pair, this lone pair, and here that single bond. So this type of lone pair are called localized lone pair. In class also we discuss. But if suppose this lone pair and along with that here one pi bond is there, so through orbital diagram we can understand this is the pi bond, and this lone pair, if it is there just adjacent to that, so always remember such type of lone pair will become delocalized lone pair, and delocalized lone pairs never present in their hybridized orbitals. They will degrade their hybridization, they will come into pure p orbital and same in that same plane, and they will get delocalized. So here hybridization of nitrogen, if we'll see, it was before sp3 but now it became sp2, and one pure p orbital in that this lone pair is there, means delocalized lone pair is not present in hybridization. So in that pure p orbitals, pi bond and delocalized lone pairs are present. So here that you can see it having here 2 electron, and here it having only 1 electron, that pi bond. So that 2 electron moving from high electron density to low electron density. So electrons are moving in this manner. Clear? So here total how many pi electron? 4. 2 here and 1 here and 1 here. So total 4. So here that only conclusion, that sigma and lone pair, which lone pair? Localized lone pair present in hybridized orbital, but pi electrons and delocalized lone pairs always present in pure orbital. In resonance and hyperconjugation do not participate with hybridized orbital, means resonance and hyperconjugation do not do participation with that hybridized orbital. In that whatever electrons are getting dispersed or getting displaced, they are always taking place through pure orbitals only, not hybridized orbitals. Now you can see that same its application of this orbital diagram only, that as here CH3 CH2 Cl reacting with NaOH, so SN2 reaction, means this is nucleophile, so it will attack and this leaving group. But here reaction is this one, that OH came and NaCl formed. But suppose if here a double bond is there, then you know that here that p orbital and this chlorine having 3 lone pair. In that, one lone pair will become delocalized lone pair, remaining 2 lone pair will be not delocalized lone pair. Why? Because remaining p orbital, even they want to get delocalized, their p orbital will be perpendicular to this p orbital, so they cannot delocalize. So only once degradation of hybridization will happen, and it will be present in that one lone pair will be present in pure orbital. So due to that, this bond here also electron density will flow, high electron density to low electron, means as electron density here more, bond order will be more. Now further reaction is not possible. Similarly, you can see this is orbital diagram of benzene. So for benzene, you can see that here this p orbital and this p orbital also overlapping with each other. So overall, this is the overlapping. That's why electron is getting delocalized, and that's why benzene actual structure is that electron delocalized, that which we are forming. Clear? Resonance hybrid. Next, moving further, now you can see here also that one lone pair will be delocalized, one lone pair will be still in localized form only in hybridized orbital. So electron moving from high electron density to low electron density, high electron density to low electron density. Similarly, here you can see in this carbocation that here vacant p orbital is there, here vacant p orbital is there. So electron will move from high electron density to low electron density like this. Clear? Similarly, here you can see carbon ion. So in carbon ion, here 2 electron, but pi bond having only 1 electron. So electron will move from high electron density to low electron. All those things will help you while that chemical reactions of all organic compound, how that bond is breaking, that everything. Similarly, here you can see free radical is there. So here it having 1 electron, here also it having 1 electron. Oh, I'm sorry. So here how many electron is there? So here it having how many electron? Yes, you can see here that it having one, that vacant orbital. So here that, sorry, pure orbital, and here also pure orbital. 1 minute. So overall electron not moving, but yes, delocalization somewhat happen. So overall this is having how many pi electron? 3 pi electron. Now moving after inductive and orbital diagram. Inductive is temporary. Now we will discuss resonance effect. After that we will discuss. So resonance is what? That 2 or more than 2, like suppose for example some compounds cannot be completely described by 1 or 2 Lewis structure, means 1 Lewis structure. So for that 2 or more Lewis structure is required. So that 2 or more Lewis structures are only called resonating structures. So 2 or more than 2 representation are required to tell all the properties of the compound. That phenomena is only called resonance, and that more than that 2 or more than 2, that all those structures are called resonating structures or Lewis structures. They are hypothetical or contributing structures, canonical structures, or Lewis structure or Kekulé structures. Through this all resonating structure only we can come to conclusion of resonance hybrid. So resonance hybrid is the real structure. Those resonating structure, let's suppose more than 2 resonating structure, 2 or more than 2 resonating structures are there. So those resonating structure which is more stable, that will have more contribution in the formation of resonance hybrid. So higher the stability of resonating structure, higher will be its contribution in the formation of resonance hybrid. Okay. Next, moving further, what are the conditions for that any compound that it will show resonance? So compound must have at least 3 parallel p orbital. Like here we saw that minimum how many for resonance should have? Parallel p orbital 3. Then only resonance will happen. So compound must have at least 3 parallel p orbital on adjacent atoms. Compound must be planar, means sp2, and conjugated. Conjugated means pi, pi single pi, pi single lone pair, pi single positive charge. This all those where that electron density can delocalize. So compound must be planar and it must be conjugated. Like here, this you can see, this is the meaning of conjugation. Like here, this negative charge and this one. So how many? 3 parallel p orbital. This is also sp2 because of its degradation of hybridization, and this is also sp2, this is also sp2. So compound is planar, these orbitals are perpendicular, and electrons is moving from high electron density to low electron density. So compound must have minimum 3 parallel p orbital, must be planar, must be conjugated, means pi single pi, pi single negative, pi single positive, pi single free radical, so and so forth. In this resonance, always remember position of atom will be always fixed. Position of atom is not changing. That is only difference between that resonance and tautomerism. So here in resonance, that position of atom is fixed, but their position of atom is oscillating. Here position of sigma bond must be fixed. Only pi and lone pair. Which lone pair? Delocalized lone pair only will change, and all resonating structure must be separated by this double-headed arrow. Next, another thing that you can see, extended conjugation versus cross conjugation. So extended also should have 3 segment. 3 segment means lone pair, double bond, like that, and one double bond. So this is the 3 segment. Similarly, here also it must have at least 3 segment. Here electron density, this one is a differentiating. Electron density moving in same direction, whereas here electron will move in opposite direction. Like here you can see one lone pair is delocalized lone pair. So electron moving from high to low like this. Whereas here high to low this side or high to low this side. So this is cross conjugation, whereas this one is extended conjugation. Clear? One very important remarkable point, that extended conjugation is more stable than its analogous cross conjugation. Analogous means it must have, both should have same parallel p orbitals, parallel p orbitals. Like here you can see that generally what electron will flow more in that extended as compared to cross. Like here you can see the generally extended is more stable than cross. Why? Because more the electron will flow from high electron to low, means electron kinetic energy will release. Due to that, overall energy will decrease of molecule, and that energy is only called actually resonance energy, or due to that molecule will become more stable. Here you can see in extended conjugation is more stable than analogous cross conjugation. So here in cross you can see this is the cross, double single double. Here also double single double. Then after double. So here total how many parallel p orbital? Double single double and double single double single double. So total how many parallel p orbitals? Each double bond having 2, so total 8 parallel p orbitals, means in that electrons are flowing. Here you can see in that only 3 parallel p orbitals, means only 6 parallel p orbitals are there. Here sp3, so conjugation broke. So even though it is extended, but it is not analogous series, because it having only 6 parallel p orbital, but here it having 8 parallel p orbital. So it is not analogous series. So in that cross only will be more stable, because here electron is getting more delocalized in 8 parallel p orbital. Hence it is more stable than extended. But analogous, here you can see 6 parallel p orbital, here also 6 parallel p orbital. So this is sp3, here sp3. So overall here double single double and double single double, and here double single double single double, means 6 parallel p orbital, 6 parallel p orbital. So in analogous, always electron will move more little bit in extended as compared to cross. So extended is more stable than cross in analogous. That's it. Next, moving rules for resonating structure. So in questions they will give you 4 resonating structure and they will ask which resonating structure is here valid. So what is that rules? All those rules you must remember and apply in sequence. Like here, each resonating structure must be valid structure, means it must follow octet rule. Octet rule means if it is neutral, it must have 8 electron, or if it is having plus minus charge, means formal charge. So along with that octet rule also it should be valid. Means suppose for example chlorine, as we discussed. So chlorine having 7 electron valence electron. If it is having -1 means it must have 8 electron. If it is having +1 means it must have 6 electron in that structure. Then it is octet rule is valid there. Okay. Next is that resonating in class we discussed several examples. Next, each resonating structure must have same number of unpaired electron. Like with one resonating structure, another resonating structure when you are drawing. So both resonating structure must have total same number of unpaired electron. Then only both resonating structure is valid. Next, nuclei means atom will not move. So nuclei of atom must be fixed. And if opposite charge is there on adjacent atom, then usually we will neglect and we will form bond by negative and positive. So this 4 rule, and along with that some examples which I discussed to you in your copy. Revise that all those. If still you are getting doubt, personally you can consult. Next, here that total number of resonating structure, how to calculate. So here you can see AlCl3, so Lewis acid. So this Cl will go. So here positive charge came. So this positive charge can go this side also and it can go this side also. To total how many resonating structure? 3. Through resonating structure, this is its resonance hybrid, and AlCl4 -1. Overall here it is +1. Overall here it is +1. Next, here also AlCl4 came, so here it is plus. Now here one way is that you can draw all resonating structure of that compound. Another is that what way I am guiding you, listen carefully. Already in class also I discussed, and like that you can calculate all resonating structure without drawing. So here you can see 1, and then after this is the one first resonating structure, and then after this positive charge will go from here to positive single double, means double bond will come here and positive charge will come here. So that is the second resonating structure. Again from here positive single double, so it will come here. Now listen, this carbon is the bridge carbon, means from here it can go this side also or it can go this side also. Let's suppose first we are going this side. So from 3, here double bond is there, so positive single double, so double bond came here, positive charge, so fourth resonating structure. Next after from here, this one is the 5th, then 5th to this one is 6th. Another is that from here it can come to here. Sir, then it will be different. It will be same. No, it will be not same. Already we covered this one, then this one, so we are covering, sir, it will be same. No, it will be not same. It will be different. So what trick I am giving, that only you follow. So from bridge head you have to cover both direction. So once again 1, then after coming to 2, then after 3, then after 4, then after 5, then after 6, and 1 from this side 7. Next from this side also we will cover. So then after 8, then after 9, again bridge head. So from 9 this is 10, and from 9 this 10 already happened. From this side again 11 to 12, and 12 to 13. So total resonating structure 13. Similarly here also removed, so positive charge came here. So here here positive single. So here positive single, we cannot go this side, so we'll go this side only. So 1, then after 2, then after 3, then after 4, again you can see this is bridge, then after 5, then after 6. From bridge, since this direction is covered, So we'll go this way. So from here, this one 6. So once again 1, 2, 3, 4, 5, and from 4 this side one 6. So total resonating structure 6. Similarly here also you can see that AlBr3, so it will become AlBr4 minus. So here it will be positive. So 1 with respect to here, then after 2, then after 3, and then after 4. Clear? Now here positive charge is there, but here double bond now came. Are you understanding? Here double bond now came, and here double bond now came. All double bond interchanged. Means with respect to here 4, now we can go to 5, 5 to 6, and 6 to 7. So total resonating structure is 7. Similarly here O minus is there. So O minus, so this phenoxide ion with respect to this 1, then after 2, then after 3, then after 4, and then after 5. So total 5 resonating. Next you can see this one. So here it is again NaOH. So taking that this acidic hydrogen, and it became phenoxide ion, sodium phenoxide ion. So here it is first resonating structure with respect to O minus. So 1, then after 2, then after 3, then after 4, then after 5, then after 6 bridgehead, and then after 7. Clear? Next from this direction is covered as we are moving in this cover. So we'll go this way also. So from here 8, 9, and 10. So total resonating structure 10. Similarly here O minus. So with respect to this 1, then after negatives, negative, single, single, we cannot go. So negative, single, double. So 1, then 2, then 3, 4, here 5 again bridgehead. So this direction we are covering. So now this direction we will cover. So 5, 6, 7. Now from here 8, 9. So total how many? 9 resonating structure. Similarly here again O minus. So with respect to this, if you are not learning this trick, means very difficult to draw all those resonating. Surely we will miss some and you will get wrong answer. So here it is -1. So with respect to this 1, then after 2, 3 again bridgehead, 4 bridgehead, 5, 6, 7, 8, 9. Now with bridgehead, since this direction we are covering, so this direction we will cover. So from here, how many done? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now from here, with respect to this 10, 11, and with respect to this 12, 13, 14. So total 14 resonating. Similarly here O minus. So with respect to this 1, 2, 3, 4, 5, 6, 7. A bridgehead this one. 7, 8. Again bridgehead. Then 9. Again from here 9 to this direction is covered. So which direction we will cover now? This one. So 10, 11, 12, 13. Similarly this one. This direction covered. So from here, since this is the bridgehead, no? Once again listen. 1, 2, 3, 4. We are going this way. So 4. Next after 5. Then after 6. Then after 7. This is the bridgehead actually. This is the bridgehead. And this is the bridgehead. Clear? So here 7, 8, 9. Now from 7 to this one done, this direction. So we'll go by this direction. So 7, then after 9 already done, 10, 11, 12, 13. And from here 14, 15, 16. So total 16 oxidation and that resonating structures. Now coming to naphthalene. So in naphthalene, that you know that this both are benzene system. So here we can draw one benzene and another this. So you can see that this benzene is, let's suppose I am giving P. So this benzene is Q. So next we can make here Q. So this is the Q. This is the Q benzene. So here it is Q. So here this is nothing, because you know that overall periphery should be in conjugation. So double, single, double, single, double, single, double, single, double, single, like that. So here that this is the Q and this is nothing. So in first P and Q is done. In second Q is done. So P we will draw. So this is nothing. So in this how many coming? 3 resonating structures. Similarly anthracene we can calculate, like here P, after that next Q. So by default here P is coming. Next after that first PQ done. So second we will draw PQ. So in second already P came. So now this is Q. Then third. So as here we drawn Q. So by default here P came. So in third only Q. So total how many resonating structure? 4. Similarly coming to here, that phenanthrene. So phenanthrene also each benzene, both type of benzene PQ we will draw. So overall total it is coming here 5 resonating structure. Now here in benzene P, so here it is P, here QQ, PQ, QP. So total 4 resonating structure. Similarly you can see here also 2, here also 2, here also 2, here also 2. So total 2 to the 4. Like here 2 to the 2 to the power 2. So total 4. Similarly here 2 to the power 4, 16. Similarly here 2 to the power 3, 8. Now after that rules for drawing resonating structure, now here we are discussing what are the rules for stability of resonating structure. So they will give that 2 resonating structure and they will ask which one is the most stable resonating structure for this compound. So always this rule should be by heart in your mind, and you should apply these rules in sequence. Like resonating structure having complete octet is more stable than those which having incomplete, means formal charge and all, they are relatively less stable. Resonating structures having higher number of covalent bond or less negative charge, less charge is more stable. Resonating structure negative charge on electronegative atom and positive charge on electropositive atoms are relatively more stable. Resonating structures having opposite charge near to each other and like charges away from each other, due to that repulsion less, so it more stable. And last, resonating structure more having benzenoid segment is more stable, like Fry's rule. Like here you can see in this here that both having that benzene structure. So this resonating structure is relatively more stable as compared to here. Like here benzene one segment is there, but in another benzene segment is not there. So in this both, this resonating structure is more stable. So this is called Fry's rule, that in resonating structure which one having more benzenoid segment is more stable. Clear? Next, what is the difference between resonance and resonance effect? Because we discussed that temporary effect, then in permanent effect we discuss inductive effect, plus effect and minus I effect. Now we will discuss resonance effect, that delocalization of pi electron through orbital diagram concept, which we discussed, that electron moving from high electron density to low electron density. So here also delocalized lone pair, localized lone pair. So here now we will study resonance effect. So resonance, here you can see that here delocalization of electron already happening, double single means minimum 3 parallel p orbital there, planar there. So here resonance is happening, means conjugation is there, but attached atom is hydrogen, which is a reference atom. So here resonance effect is not there. But here you can see NH2 having lone pair. So this lone pair will delocalized with respect to this benzene system. So when electron is getting delocalized, when electron is moving towards the ring of attached atom or group, then only it is called resonance effect. Since this electron is moving towards the ring, means it is giving electron to the ring, then this is called plus R effect. This is electron donating group. Whereas NO2, here not lone pair is not there, it is electron withdrawing group. So it will withdraw the electron from this conjugated system. So this is minus R effect. Means always understand from here that resonance is the conjugation, whereas resonance effect is the whatever the attached atom or group of atom is there with conjugated system, if it is giving or withdrawing the electron from the system, that is called resonance effect of that attached atom or group. So resonance effect is the permanent, this is not distance dependent, and permanent polarization of pi electron or those lone pair which is delocalized lone pair, that only will happen. So this we will study and will continue in part 2. So in part 2 we'll try to cover this all those concepts, resonance and hyperconjugation. Thank you very much.